Good morning, everyone. Welcome back to the Precalc series. My name is Meek, and I'm going to be teaching this class way better than your teacher can by covering things in depth the easy way. Let's get right into it. So what is average rate of change? Well, first let's start with what's familiar. We've all heard the word normal rate of change before, and we have been conditioned to associate that with the slope of our function, and rightfully so. If I were to draw a linear function right here, I would be able to find the slope of it, m, let's just say m equals 1 for this case, and that would be the rate of change of my function. I'm going to abbreviate it as ROC for this video. That would be the rate of change of my function, the rate of change of y over x. So we may remember the slope formula, that the slope of our function m equals the change in y over the change in x, and that's a correct formula. However, that formula only works when our function is linear, okay? Because when our function is linear, the slope between these 2 points is exactly the same as the slope everywhere else on our line. However, if I were to give us a different graph, let's say the graph of a parabola, and I were to analyze the change in y divided by the change in x between these 2 points, that no longer equals the slope, because the slope between these 2 points is changing. I'm not looking at a straight line anymore, okay? So that's where average rate of change comes into play. Delta y over delta x is equal to the average rate of change. I'm going to abbreviate it as AROC, okay? It just so happens that in the special case when we are dealing with a linear function, the slope of our function equals the average rate of change over any interval, okay? And notice what I said there, over any interval. The average rate of change is always something that is taken over some interval a to b. Inclusive means hard brackets. So the average rate of change is another way of saying average slope. So the average rate of change of our parabola here is the average slope of our line across this interval. So granted that our previously understood slope formula is our formula for the average rate of change, let's expand that out a little bit. We know the change in y is equal to y2 minus y1 over x2 minus x1, the change in x, okay? So this can also be rewritten as f of b minus f of a over b minus a, where we are evaluating on some interval a to b, okay? Let's just continue using this parabola as an example. This is point A, and this is going to be point B, okay? So that means B is our second point, which is why it is present here. Y2 is the second point, x2 is the second point. And so now this formula is all we're going to need to evaluate our average rate of change. Let's do an example. F of x equals x squared plus x plus 2. And we want to evaluate the average rate of change of this function on the interval 0 to 2. Okay? So let's bring down our equation. F of b minus f of a over b minus a. Okay? So first let's compute b minus a because it's easy to compute. It's just going to be 2 minus 0 equals 2 minus 0, f of b. So let's first compute f of b. F of 2 equals 2 squared plus 2 plus 2 equals 4 plus 2 plus 2 equals 8. So our f of b is going to be 8. We plug in 0, which means this whole term evaluates to 0, this whole term evaluates to 0, and we are given that f of 0 is all that is remaining, our constant 2. 8 minus 2, okay? So we're going to bring this down, re-simplify it once more, and we get 6 over 2 equals 3. That, gentlemen and ladies, 3 is going to be our average rate of change on the interval. Now, another way of expressing average rate of change is called the difference quotient, okay? And the difference quotient becomes much more useful when you move beyond precalc. But first, it's useful to be introduced to it right now. So first, we want to bring over our formula for average rate of change that we've been using up until now, f of b minus f of a over b minus a. So let's consider this in reference to our parabola right here. You'll notice that b minus a was our change in x from the previous formula. So let's represent it as such. Let's say b minus a equals delta x. Now, another thing I want to do is I want to get b by itself. B equals delta x plus a, or a plus delta x. Okay? So, given this notation, using delta x, I can rewrite this formula, and I will rewrite it as such. F of b, we have shown, is equal to a plus delta x. So f of a plus delta x minus f of a over delta x is exactly the same thing. Okay, this also equals my average rate of change. So let's use this with another example. Let's say I give you f of x equals 4x squared plus 4 minus x. Let's calculate the average rate of change on the interval 1 to 4, which means our a is going to be 1 and our change in x is going to be 3. Remember that our change in x equals b minus a. So first, let's evaluate the top. F of 4. So we're going to plug in our x in all of these places, and our x is 4. So we're going to plug it in like this, and let's evaluate. What's 4 squared? 16. What's 16 times 4? 64. Plus 4 minus 4. So these two cancel out, plus 4 and minus 4. Therefore, f of 4 equals 64. Now let's evaluate f of a. F of a is f of 1. Okay, so we're looking at f of 1. That's going to equal 4 times 1 squared plus 4 minus 1, which is equal to 1 squared is 1 times 4 is 4 plus 4 minus 1, which is equal to 7. So our difference quotient now evaluates to 64 minus 7 over our change in x, which is 3, which equals 57 over 3. That is our average rate of change over the interval. Average rate of change, like we mentioned before, a mention of the average slope. So we can say the average slope over this interval is 57 over 3. And since that's the average slope, you can use that slope to determine the slope of a secant line. What is a secant line? It's simply the line that goes through both of these points. So if you want to find the slope of the line that goes through both of that points, that is going to be your average slope on the interval, which in this case was 57 over 3.